Thanks so much. So like I mentioned, for the judges, please make sure that you have your Google form ready to go. If you don't, let me know and I will send you the link in chat. And as well for clients, there is the client evaluation form. If you'd like to fill that out while the presentations are happening, you are more than welcome to. So I will announce each group that's presenting and the group that's following up next so that they can be prepared. The groups have 3 minutes to present and 5 minutes for questions. And the questions are from the judges. If there is time in between, if the client has a question, they can ask a question, but I do need to keep things as tight to the schedule as possible because we are running a bit late. There will be time after all of the presentations are done for clients to speak with each of the groups as they'd like. So let me just double check who's starting. Okay, so our first group is C23 Portable Orator.
Perfect, that's us.
Are we good to go?
Yeah, I think so.
Sounds good. Give me 1 second.
Just before you start, sorry, I will flash like a 1 minute counter. I'll put my camera or my phone up so you can see the time.
Okay, sounds good.
Yeah. So you can go ahead and start whenever you're ready. Thank you.
Yep. All right, Victoria, you ready? Okay, hello everyone. We are the TalkBox team C23, and we named our device the Portable Orator. And what we're doing is essentially a device which will allow people with speech impediment to communicate during their everyday activities. So essentially what the device needs to do is just allow for the user to select phrases in an ergonomic manner and speak those phrases out loud so everybody else can know what's going on. So here's our quick solution. This is the concept drawing of it. So we came up with a LCD screen and a joystick mounted on a gooseneck mount. And the focus of this solution is really freedom of movement and ergonomics. It allows the user to essentially adjust it in any way they want using the gooseneck mount. And they can also place the joystick wherever they want on the wheelchair. So our device consists of 4 main components. Here are 3 of them. So the first one is the Raspberry Pi. We decided to go with the Pi because it's a lot more powerful than the Arduino, and it allows us to implement powerful functions such as text-to-speech rather easily. We have an LCD screen to allow the user to select inputs and caretakers and such to edit the phrases. It's pretty powerful. And the gooseneck mount. And the gooseneck mount is obviously there for ergonomics to allow the user to place the screen wherever they feel the most comfortable. And lastly, the joystick. The joystick is a little bit of a result of our budget constraints, but I think we did pretty well considering, and I think we picked a pretty ergonomic option with a pretty large handle, which will allow people with disabilities to easily use it. And we also made a 3D printed cover for the whole device, and you can see at the bottom it has a little slot to mount the gooseneck. And now we'll move on to our software and live demonstration with Victoria.
Perfect. Okay, I'll just get you guys to look at my camera here. I'm not able to pin it, but this is our main menu here, you can see. So we have all of our categories that store the phrase bank. So social interactions, home interactions, caretaker interactions. Now, one of the big things that we wanted to do was enable people to talk with smart home devices. So for instance, you can go like this. I have a Google Home next to me here.
Hey Google, what is the weather like?
Right now in Ottawa, it's 18 degrees and partly cloudy. Today, it'll be mostly sunny with a forecasted high of 21 and a low of 8.
So you can see that it does interact with the smart home devices, so you can get it to do many things. As well, we have settings to make it more personalizable. So you can change the background color and the text. So you have your day mode, night mode, and black and yellow for people who would like different contrast. We also have different settings for the joystick. So we have our scrolling options here.
That's
and in that we
Victoria,
have the,
sorry. Thank you very much for the presentation. I will hand it over to judges for questions, and the judges have 5 minutes.
If I may jump in with one, Julius here. Sorry, you may have covered this, but may I ask if it's charged by battery or the battery life, or if it's a live plug?
It's supposed to be plugged into
Yes.
the wheelchair as it is used.
Yeah, it'll use the wheelchair battery power through an XLR cable or USB, depending on what the user has.
Wonderful, thanks.
Mm-hmm.
If I have oh, sorry, I see another judge is on mute, but asking a question.
Rosalind, quick question. Can you change the speed at which the voice comes out?
No, that's one of the things we wanted to implement later in the settings menu. That would be one of the next steps we would take.
The change in pitch and the change in speed or whatever. That's what you're going to work on. Okay, thank you.
Yeah, and then also we would like to also add maybe a wave so you could have a female voice or a male voice as well.
Okay, thank you.
Yeah, just to add on that, there's 1,000 ways we thought of that the user can customize their interface, but we just ran out of time, unfortunately, to implement all of those ideas. So we're just kind of stuck with what we have right now. But if we were to continue to develop this, yeah, we would add, hundreds of options.
Okay, thank you.
How easy is it to change the phrases used? You reprogram the Raspberry Pi?
Yeah, so I can actually give you a quick demo here. I'll just give you a brief idea how to do it. So what you would do is you would exit out of here, and we have the XLS file here. So you would just load it onto a USB stick, put it into your computer, modify the XLS file on the computer, and then put this back in, and everything updates again.
That's great. Thank you.
Yep, and I think you can do it on the Pi as well. It's just a little more awkward, but if you need to do that, the option is also there.
Yeah, just with the stylus. And then you can also see here, we have the scanning menu option too. So it automatically scrolls. And if you want to make a selection, you either just push left or right or up or down, and it'll make a selection. You just have to bump the joystick.
It's Shadi here. So when I spoke initially about empathetic design, there is no category of products or solutions that I think is more in
device on.
design. Can you guys hear me?
Yep.
Yeah.
Yes.
I don't think there's a category of product or category of users more in need of empathetic design. When we design, sorry.
Do I need to put the lensing device on when I present?
I apologize. Sorry, say that again. Okay, anyways, I think what's key here is when you design a product for folks.
Okay, sounds good.
I'm sorry, is someone asking a question?
Sorry about that. Somebody had their mic.
Oh, it's okay, no problem.
I muted them.
Yeah, I find this category to be extremely delicate in terms of defining needs and addressing needs. Too little feature, and the user would require a solution. I can hear myself.
Sorry, there's a little
And-
bit of echo through your speaker.
Yeah, that's okay.
Is there?
And-
Okay, I'll turn my.
Thank you. So too many features and the user would need, too little features and the user would need more than one product or solution to do the job they need and the function they need. And too many features and the user get bogged down with things they don't need. Accessibility products are there just to kind of make life easier for someone. You need them to just work and to do what you need them to do without you having to do a lot of action. I believe that you guys addressed each one of these aspects in a very good way. I didn't have a full-blown kind of view of what you have in the product, but it really looks what I call thrifty in design. It is the old concept of as little as possible, right? So you guys did that. I really think this is a well thought out product.
Thank you. Yeah, I'd give a lot of credits to our clients as they gave us a lot of feedback, and we use most of it and try to incorporate it, and it was really useful. So I'd give them a lot of credit as well.
Thank
One
you.
one little tip, if I may add one little tip. As you refine this solution and this design, you're going to be talking to a lot of different people, different folks, different ethnicities, different accents, different languages, right? I mean, I have an accent, obviously, right? So what I find is interesting is empathetic design is really important, but design for diversity is super important, especially when there is a human to machine interaction, as there is in this case. Okay, so please make sure that you're covering a good subset of your potential users, and that is reflective of the diverse, like I said, ethnicities and languages and accents that people speak, right? Plus, people that require these type of products sometimes may have some vocal issues to start with. So you might find that the voice recognition can be a little bit difficult unless you train it with that subset of users.
Thank you, Shadi, and thank you, C23, Victoria and Michael. So next up,
thank you for coming out.
Next up,
Thank you, everyone.
Is C13 Super Speak. The following group will be C22. For this group, can we just, and for the duration of the presentations, please make sure your microphone is muted if you're not speaking. It will take the spotlight away from people who are actually trying to present. And for this group in particular, if you can have your view on speaker view, as Zainab has a presentation that you'll be able to see from her screen. So I will hand it off to Zainab, and I will start the timer for 3 minutes as soon as you begin.
Thank you. Hi, this is Team Super Speak. Speech, a thing we take for granted, but over 400,000 Canadians experience speech disabilities. Imagine after a presentation you had a question about this project, but words simply couldn't be formed. How frustrating would that be? The matter grows more concerning. A Canadian study shows that almost 1 million Canadians with dexterity disability have reported having some level of unmet need for everyday activity. One example is our client who came to us representing a population of disabled community that suffers from low dexterity and cognitive speech issues, making them rely on caregivers to complete everyday tasks. With the growing senior population, these limitations are way too common. This is why we developed Super Speak, a product that assists people with dexterity and cognitive speech limitations to be able to automate communication and requests through the use of a joystick. Our team worked closely with our client and developed a device that provides an LCD screen that demonstrates phrases and icons for the user, a joystick that allows the user to scroll through and select phrases, a simple user interface that allows the caregiver to edit phrases from anywhere, from any device, and finally, a device that is lightweight and easily mounted on a wheelchair. Currently, the market is focused on device-to-device communication, while we are focused on complementing that with device-to-human communication. Despite the fact that our product is more affordable than existing products, Super Speak is an open source and is adaptable for future upgrades. In addition, interaction with our device is not limited to a phone application. We use a screen that is shown to the user at eye level. Let me demonstrate to you what we can do. The first interaction, the user will see the front screen. They can use the joystick to scroll left and right to scroll between the categories. Once they're in a category, they can press down, and here they are in a category. Then they can scroll in a similar way and press down, and the phrase is output out loud. Let's say the user would like to add a new phrase. They can simply go to a web page where they can insert the phrase that they would like to add and select the category they wish it to be added to, click submit. Just like that, the phrase is added to the database. Hence, we can go back to the device to talk to a devices category, and we can switch, and we can show how it talks to Siri.
Hey Siri, hey Siri, hey Siri, hey Siri. Open calculator.
And there you go. And that is not the end. Super Speaker was able to create this MVP within a span of 2 months and only $100. Imagine what we can do with more resources. Thank you.
Okay, thank you very much, Zainab and C13. We're under by about 10 seconds, so I don't know if there's extra points for that, but good job. I will hand it over to the judges for 5 minutes of questions.
So I have a question, not as a judge, but as someone who was part of the origination of this project. And that is both of the previous, this and the
Lights
previous.
on, turn lights on, turn lights on, turn lights on, turn lights on, turn lights.
Both this and the previous version have used joysticks, and smartphones and tablets have become, you know, sort of a universal interface. Were these considered as an option rather than a joystick? In other words, moving your fingers around on a screen, touch screen approach?
So the reason we decided to go with the joystick and not a touchscreen, because our client came to us with a large population that all suffer from dexterity at different levels. So if it's just a touchscreen, then it's pretty much like a cell phone or a smartphone. But with a smart button or a joystick, they're able to do pretty much anything with more ease of movement with like their wrist.
So you're really talking about a question of capability, that the idea of diverse users. I agree with you on that.
Awesome, thanks, Paul. I will just add that clients can also ask questions during this period, just in case the judges, it's also useful for the judges to hear questions from the clients as well. So feel free to jump in during the question period as well.
Yeah, this is Roy Ballantyne, client. I have a question. Did you do any testing of the product that you had created?
So in terms of testing, we made sure that the database communicates with the device instantly. So as demonstrated, you can add a phrase from any device that is not really connected to TalkBox, and then it will.
Sorry, if I can interrupt, perhaps I was unclear. Did you test any people, any potential users?
People with the right, like with the dexterity level that the device is meant to. Unfortunately, we were not able yet, but this is something that we are actually looking to work on in the near future. But in terms of also the other testing we did was talking to other devices, which we did with Siri.
Thank you.
I am impressed with your ability and your insight into this category of users, guys. I really do. Both teams, this one and the previous one, I really don't know. Sorry, I really don't know what year you're in or what level you're at the university. I taught design at undergrad and grad level, and I've seen people that get it and others that don't. I think, again, the word empathetic, right, is very important. I think you guys have some really interesting insight, and it's very obvious in the way you're addressing the needs in both products. I wish I had the opportunity to teach you one day, honestly, because I like to work with people that do find the user needs and are able to relate to them. So good job. That's all I'm going to say. I do have one little comment on both, if I may, for both teams. Just keep an eye, like when we start talking about the use of screens and I know you're using Arduinos, which are fairly cheap in terms of cost, but when you're designing for this category of users, affordability is extremely important, and you have to keep in mind how you're going to efficiency engineer your product. I don't know if you used this term before in your courses, but efficiency engineering is super important because it takes the product, it takes the design, and you start looking at ways to make it function the same way with the same durability and reliability, but you're taking away some cost out of it. And that enables you to present it to a segment of users that is wider because the affordability level is higher, right? So it's good for you and it's advantageous to this category of users as well.
Okay, thank you very much. If there's no more questions, we will jump to our next group. Thank you, C13.
Sorry, Lionel, is there still do we still have minutes for a quick question?
Sure, throw it in. Yeah.
Comments, excellent presentation. Great mark of hitting on all the stats. I noticed there was a little bit of repeat on when Joystick selected down. Is there any addressing towards, is it when it's held down it repeats, and then once it's released it stops repeating its phrase?
So it's not supposed to actually do that. Like the joystick reads only one input, and the joystick works by mapping out inputs by the keyboard. But the repeat is just a little unfortunate glitch that happened right now, but it's not supposed to behave that way.
No problem. Thanks so much.
Okay, thank you. Thank you, C13. Thanks, Zainab, for the presentation. The next group is C22, OCR engineers, and the following group will be C31. So I'll hand it over to group C22. I'll start the timer as soon as you begin.
I'm having trouble changing my background, but doesn't really make any change. Just before I start my presentation, I want to let you know that I'm using my iPhone.
Oh, it looks like you cut out or you...
Am I back?
Yeah.
Am I back?
Yeah.
All right. So before I start the presentation, I just want to let you know that I'm using my iPhone to do the demonstration. And so I'm connected on the site. So I'll just need at some point to change my screen. And I'm not sure if you guys can pin my screen so that you can see whatever I will do with my iPhone. If it doesn't work, I'll do the demonstration directly from my computer, but might just be like less realistic. But the app, it's like my solution is still functioning. So yeah. Do you guys see my screen?
Yeah, we see your screen.
All right, so we are team C22 OCR Engineering, and we are responsible of working for a sign and price tag reading assistant for visually impaired user. My name is Spiridon, and I'm talking on behalf of my team member Joseph and Dave. So the problem was that our client, due to COVID, is having trouble going outside and being autonomous due to the sign and sign that tells to keep distanciation, reading price on a market like price tag, because he cannot ask people to read for him the price because he's visually impaired and he needs to keep distance. So he asked us to build an app that will be capable of doing OCR, object character recognition, and print a text that will do text to speech and read it out loud, whatever is in the picture, to him, and be capable of using the app. He wants an app that's easy to use, reliable, require as few steps as possible, and is visually appealing and quite easy to use. And we might ask, who cares about those problems? Our client care about this problem. Our client is visually impaired and he wants more autonomy. So on the market, there are current solutions that do this, those kind of OCR feature with text-to-speech. Google Lens and Seeing AI does it, but the problem is that they use small button, not intuitive to use, and require a lot of steps to accomplish a task, and so it makes it hard for our client to use the solution. So why our solution is better than those? Then our solution is really made for visual impaired user because it's easy to use, require a few steps to do OCR with text-to-speech, has larger button, and is pretty reliable, is up to 85% reliability when using the app. So you're pretty confident with whatever you take a picture that will be relevant, and you will get more autonomous. And we then handed our app to our client, and he tested and was pretty happy with overall whatever we have built. Let me share my screen now. Do you guys see my screen? My iPhone screen? Maybe I should.
So we won't be able to see it if you're speaking because it takes your microphone as the primary one. Yeah.
I'll do it directly from my computer. Just give me a second. I was ready. So OCR building T. So do you guys see my computer screen?
We do, yeah.
Okay, I'll just share my audio. I'm so sorry about this. Just share with, do you guys, okay. So my app is doing text-to-speech recognition with selected text recognition and price recognition. So we'll just go with this feature, which is capable of inputting an image and directly print an image, and you can select the text that you want to be read. So you want to get read this text, so you just select this text, and the text will get printed. And then you need to select ABC, which is the button, a label that will read out loud the text. Did you guys hear it? Okay. All right. Perfect. Thank you.
You're at time. Sorry.
Okay, I understand. Perfect. Yeah. Thank you.
Thanks for the presentation. I'll hand it over to judges and clients for 5 minutes of questions. Go ahead. Oh, Rosalind, you might be muted.
Hi there, Spiridon.
Yes, Spiridon.
That looks wonderful. Obviously, you will be able to use different languages in this situation, or you're planning on it?
Okay, so yeah, like I said, we're using a database that's Microsoft Translate, so we can change the function of the app to change the language, and that's in our future work.
Okay.
So it's feasible, totally feasible, and that was one of the client requirements since he speaks fluently Spanish, and he kind of asked a bit if we let me just audio. Whenever we use the translate text to speech feature, we can select a new language, and so we put it by default in English, which is the standard language, like the official language in Canada. But he speaks also Spanish, and he was asking if it's possible to do in Spanish. And for the client needs, that's obviously doable. We could have added another button to select a new language, or yeah, to have the selection of language. Yes.
Okay, thank you.
Hey, Spiridon, this is Julius. Just wanted to compliment a great point for comparing to the existing big numbers and big names, the Google Translate.
Yes, thank you.
So, hi, quick question from Rob.
Yeah, sure.
I was just wondering the feedback from your client. So the purpose of this app is to be able to read signs. How was their ability to read the actual text on the app is related to reading signs? Is it just require a certain level of vision in order to use the product?
Okay, so this app is really meant for visual impaired user and not visually blind. So like our client is still capable on perceiving colors from really close. From what I understood, he's capable on maybe reading. But at first, whenever he explained to us the need for the app, he really used the example of he's in a supermarket store and he has a product. Man, I'm so sorry, I don't have any product. Besides, okay, I'll take this one. So he cannot maybe read the information on the product. So he really asked something that might be capable of reading the information on the product. He also used as an example a price tag. So we have also a feature which is price tag recognition that can select a price. In the image we input, the OCR recognize all the text, but only discriminate the symbol $sign with 6-figure after. So it's capable of selecting the price and input it. About the sign, we also have a general text recognition. This one, the text recognition, which you do the general thing. Take a picture of the whole picture of the whole product and selects all the text from the picture and print it all out. And this is meant for most likely for sign or general product. But if the user wants to select a specific line of text, he can select because he's capable of seeing whatever he selects, but might not be necessarily capable of reading whatever he selects.
Got it. Okay, thank you.
Appreciate it. Thank you.
Probably have time for one more question. There's a minute left, a minute 20. It's fine if there is not any other questions, but.
If I can, I add by myself, I'll just say that what's missing from our app is basically the ability of copy text. So we have a label and we want to add a feature that will do some copying. So let's say I just add an icon, let's say this one, and I want to link this icon to copy whatever is printed there in the RAM memory of the phone, and the user can paste it whatever he wants, or maybe save it in the phone. So that's maybe for future work also plan to do.
Okay, thank you very much.
Thank you.
Thank you, Group C22. Our next presenter is C31, Camera Cover Co. And the following group will be C32. So I will hand it over to group C31 and I will start the timer as soon as you begin.
Hello everyone. Our company is the Camera Cover Co. and our product is a wireless camera cover. Our user is a 12-year-old boy with physical disabilities. He uses his power wheelchair to do everyday activities from moving around to playing video games. However, he's unable to use his arms and legs to control his wheelchair. Because of this, he uses buttons operated by his head to do everyday functions. For verbal communication, he uses the Tobii i12, which is a monitor that uses a camera and traces his eye movements to form words and sentences. The Tobii interacts with his other devices when he is trying to communicate electronically. The overall need is to cover the IR LEDs on his Tobii when he is using other electronics. This product is made mainly for people that use an eye gaze camera device and can't manually close the camera cover. The only other option on the market is a camera cover that needs to be moved manually, or in the case of our client, they use a piece of cardboard to cover the camera lights. This causes many issues as he is unable to control his ability to communicate with others, and we need someone else to cover his camera when there is an interference.
Okay, so here's our solution to this problem. So there are two parts here. One is this sliding camera cover, which slides to cover these strips of IR LEDs while leaving this camera uncovered. And the second part is this wireless button, which mounts to an existing button arm on his wheelchair and is pressed by your head to wirelessly transmit and open this cover. So here's a more detailed view. Can everyone see this screen?
We can,
okay.
Yeah.
Yeah, so here's the sliding cover. It's moved by a servo in this box with a little snap-on container. This houses the electronics, which are powered from the Tobii, consuming a minimal 9 milliamps, and are able to run off the Tobii battery with no internal power source. That snaps on. There's this larger servo mounting block over here, which holds the servo in place. And the sliding cover is operated by a little crank over here, so a simple mechanism for reliability. And here's the button. So this here is an existing arm on the wheelchair that has another head-operated button on the top. But to use this, you simply push your head against this larger disc over here. It pivots on this point and pushes a small tactile switch, which slots in on a circuit board over here, also providing audible feedback. All the other electronics, such as the wireless transmitter, are housed inside this compartment here. And now here is Cam to give you a demonstration of our physical prototype.
So here's our prototype right here. As you can see, there's the servo that's in here, and as it turns left and right, it does the cover. And if he wishes to push the button, it can close the cover, or he can push it again to close it back up just like that. And that was our product. Do you have any questions?
Thank you very much. That's time. I will hand it over 5 minutes to judges and clients for questions. Go ahead.
One question relates to the use of the head-operated button. I mean, did you mention that it has another function as well? Is there any need to sort of change functions, or you said it was an existing button? So I just wasn't clear in your presentation how this function would differ from the normal function.
So so the wheelchair already has buttons attached that he uses to move around and do everyday things. So at the start, we planned on attaching to the back of the wheelchair as well, a new button. However, we went with an idea of attaching a new button to the existing button on the side here. So the new button would be hanging below it. Therefore, it's just easier to place and just like less pieces.
So it's a button in addition to another button.
Yeah, it'd be attached to an existing arm and button.
Oh, existing arm. Oh, got it now. Okay, I was wondering how you changed functions. There you are. Thanks.
Hi. So were you able to mock up the user interface, the button at all, and just to see how it interacted with the existing button? Did it cause any issues, like any interference or activating it, unintentionally, anything like that?
Unfortunately, we weren't able to test it out with our user because of COVID and lockdown restrictions like that. So we didn't have any chance to actually test out the interference, but we did use like lights behind the pre-existing prototype to see if they blocked off LED lights, and they did do that, but we weren't able to actually test it with the client.
Thank you.
Yeah, so
you guys, this is it's awesome. I mean, it's a combination of simplicity and sophistication. I like how you integrated it with the components of the wheelchair. I don't think there's any new fixtures that are needed for this, right?
Yeah, in fact, several times we changed the mounting of the button and the sliding cover to get it to mount. So the sliding cover now, because of COVID and stuff, so a huge problem was getting accurate dimensions. So we can't do snap fits or anything. So we went with this adhesive, this removable adhesive kind of tape, and basically different methods. So we're able to mount it easily.
Is any of you guys an industrial designer or studying industrial design? No,
just like mechanical.
You've done a great job without one. I do, though, for a product like this, I really suggest you work with some industrial designer who's worked on similar products before. I really think you'll have a lot of room for optimization if you do talk to someone and they do give you some analysis on this. But I mean, yes, physical testing will yield a lot of new ideas and maybe limitations that you need to kind of take into account, and you will refine this. But I'm very impressed. Like, this is really good. This is really good.
Thank you.
One quick one from Julius here, if it's all right. Great presentation, excellent use of time there. I was wondering if there's any considerations for fail close or fail open. If the power is cut once it's already engaged, does it just remain in the closed position or does it revert back to open?
So yeah, so right now, it fails just in whatever position it was left in. However, it can be operated manually just by sliding the cover open and close, because you're working against just the gearing of the servo that's unpowered. In fact, even if it is powered, the servos, power to the servos shut off, so it could always be activated manually.
Perfect. Thanks so much.
Yeah, thank you.
Okay, thank you. That we are cutting it short for time. I don't think we'll have time for another question in there. So thank you, C31, for the presentation. Our next group is C32, the glucometer assistance, and our last presentation will be, or sorry, second last will be C12. So C32 is up next.
Yeah, sorry, one sec.
No problem. I will start as soon as you begin your presentation.
Okay. 1 in 3 Canadians have diabetes or prediabetes. A possible complication of diabetes is having a stroke, which can have several long-term lasting effects, such as decreased mobility or even partial paralysis. Diabetics have to take their blood sugar 3 times a day, a process I'd like to quickly demonstrate. So they have a lot of pieces to this: a glucometer, lancing device, test strips, and lancets. So first they have to remove or replace the lancing device. And as you can already see, this is becoming a very complex process with a lot of steps. It requires a lot of dexterity and 2 hands. So the goal of our product is to make this process easier for impaired patients. Our product provides 3 main functionalities: a place to store all the needed supplies, a place to securely hold the glucometer in an easy to use position away from the table, and a holder for the lancing device that rotates and allows the user to more easily manipulate it when they set up the lancing device to take a sample. So Colin is now going to do a quick demo of our product.
Hello, so here's a quick overview of our device. Okay, and this thing is a box which can contain lenses and stripe papers and whatever things the patients need. And here is the clamp. Here is a clamp which can hold nearly all types of glucometers here. See? Okay. And this big device is the lancing holder, which I can put the lancing device here, and it will hold tightly so that patients can, when patients using it, they can just use one hand to test their glucose. And it can also rotate, so patients can go through different directions to test it. Okay, so this is mainly all the functions of our box.
Okay, our product is superior to products on the market because it is the only one that provides a holder for a lancing device that is easy to use with one hand. Our product is cheap to manufacture and affordable for someone who already has a very expensive disease. Since the patient doesn't need to buy a new glucometer to use our product, they don't need to learn how to use a new glucometer, which could be challenging for elderly patients. Our product is the only product out there designed to help impaired diabetics take their blood sugar. Thank you.
Okay, thank you. Right on the money. 3 minutes. I'll hand it over to judges and clients for questions for 5 minutes.
May I ask the holders there? I see the 3D printed orange and pink selection. Are they modular for fitting multiple devices of different products on the market?
Yeah, in regards to your question, they are actually adjustable largely. As of right now, we have future intentions of potentially adding more sizes down the line, but we just add, there's some dimensions, at least with this configuration, we're set to the general size of glucometers and lancing devices we saw currently available to most people with this specific condition. In the future, we would like to add, as I said, we'd like to add more variations and potentially more ways to hold the glucometer and the lancing device to cater towards people with different ailments as well as just different devices. Yeah, so overall it is adjustable for other models and versions.
That sounds excellent, thanks.
Yeah. Yeah, just a quick question. So did you have a chance to work with your client with this? And they were really happy with the accessibility of it? Hello?
So we were able to show our design to Dr. Feinstone, who is our client. And he was happy with our final concepts, but we weren't able to test it due to delays with COVID.
And you know, we all know people who have diabetes. I guess my question is, where would this be stored? Like, how big was I couldn't get the size and dimensions. How big was this container that you were showing?
Floor space, it's a little smaller than a small laptop. So it's meant to be like a tabletop solution to help someone who's already a little immobile, just to improve daily routine type of things.
So it would be stored on a table is what you're telling me?
It could be put in a dresser or like a drawer or something. It's small enough to do that.
Okay. All right. Thank you.
It's time for one or two more questions if they are short. Otherwise, we can jump to the next group, which is okay. Thank you, C32, for presenting. Our next group is C12 Helping Hand, and our final presentation will be group D4. Thank you again, C32, and C12, you can go ahead and get ready to present.
All right, yep. Just give me one moment, please. I'm going to begin my screen share. Okay. Good morning, everybody, or good afternoon. My name is Daniel Clark, and I'm representing the Helping Hands group in this for our product. So before we begin, I'd like you to consider, what would you do if you dropped your pen on the ground right now? You'd reach over and you'd pick it up. You wouldn't even think twice. Now imagine if you were unable to do so. So this is the unfortunate reality for many people. They lack the ability to perform basic tasks that we perform every day without thinking twice. So this is the problem that we were trying to address with the design of our product. More specifically, the arthrogryposis that our customer's grandson has. Arthrogryposis causes weak muscles and stiff joints, but the solution that we came up with can be applied to any condition that reduces a person's mobility and improve their overall quality of life. So our product has been modified with 3 key components to meet the user's requirements. The arm brace offers support for the muscles as well as extra control. The lock release allows the user to use 2 hands to control the stick and hinge the stick in half to bring the object they're picking up close to them for easy access. And then the electronics on the bottom of the arm brace draw the tension wire for the client so that they do not have to use any their hands at all. So what kind of, now that you've seen our product, what are the other solutions out there? You'll notice with a quick search for an automated pickup stick that you will not be able to find any similar solutions. Ours is a completely unique solution that is not readily available at all. So what do we provide? We provide a unique, functional, user-oriented solution for people who require mobility assistance in their everyday life. So I'm going to take you through a quick demo now. Sorry, it's a physical prototype. So you see here a small object that weighs about ½ a pound. Here's our prototype with your arm brace, the lock release, the hinge point, and the electronics. So to utilize, you place around, engage the electronics, release, pick it up. You can see that it's now closer and easier for me to access. Going to release the electronics, and then there you go. Re-engage the lock, you just straighten, and voila. Thank you very much. That's perfect. Any questions now?
Thank you, Daniel. Great job. I'll hand it over to judges and clients for 5 minutes of questions.
Of course.
Hi, this is Rob speaking. Great job. Quick question. Just wondering about the lever. So the lever, it's kind of like you've got buttons to activate the gripper, but you've got a manual lever to activate that hinging function. Was there any reason that you went down that road instead of having both with button activation?
Yeah, so the lever has kind of a dual purpose. So with the decreased mobility that our users experience, the lever offers a secondary position for you to control the stick. So it's easier to pick up. If you're picking up something heavy, you can use both hands. Once you release it, it's for mobility and also simplicity and weight management.
Okay, thank you.
Of course.
Hi, Daniel.
Hello.
So I'm kind of laughing because at one point in my life I needed one of those things because I couldn't bend down, and but I had a device that was one-handed. Now, if a person has arthritis, they're going to have to use, so they have to use one hand, then they have to use the other hand with the lever. And I agree with what Rob said, is if you just had a button, then it would, because if you can't grasp with your hand, did your client say that that was a problem, or do you have to have a certain amount of use with your hands to be able to work one lever and then the other? What's your prognosis?
Well, the lever you can hear. I'll show you. With the lever, you actually don't have to grasp at all. You can.
Okay.
You can.
Okay. Thanks.
Yeah,
I appreciate that.
No closing.
Okay.
Same with the handle. It's been designed so that you can hold it just with the palm of your hand without having to close
Right.
it.
Okay. No, thanks for showing me that. Okay.
Of course.
Thanks, Daniel.
Did you see an advantage in using an existing product and modifying it rather than having to rebuild from, sort of a good rebuild from scratch, so to speak? Are there other models that might work to be adapted that way?
Yeah, well, actually, that's a great question. The design that we've come up with can actually, I believe that it could be applied to any like functional stick of this design, because everything, all sticks, the only important part is having the wire be able, like the tension wire, be able to pass through the handle to the electronics, which is an easy modification that can be done. So yeah, taking this and modifying as opposed to starting from scratch, obviously there was a lot of benefits of like time and not having to develop the actual stick itself as well, only having to develop the modifications. but it's also something like, yeah, it was definitely beneficial, but it's also something that could be avoided. And we could also design a completely own, like a new shaft and stick, for sure.
The one component that as a client I liked was the fact that the electronics and the motor for the pulling the wire to some tension was mounted in the armrest, which offered a very significant counterbalance to the weight of an object that would be picked up. So if you had the weight of the motor on the shaft to wind up the wire, you would have you wouldn't have that counterbalancing effect for a weak muscled arm.
Exactly, and you can actually see that it's quite well balanced. It's about in the middle point. So that was definitely our thought process when we decided on the placement of the motor, is to offer that counterbalance of picking up heavier objects, for sure.
Hey, one quick question. Have you guys thought about an interchangeable head that gives you access to different functions or objects?
Sorry, there was a little bit of static there. Could you repeat that, please?
An interchangeable gripper that can allow for different objects or functions?
Yes, we did discuss that at the very beginning. It was something that we decided not to pursue because of time constraints, but we went through multiple ideas, having like needle nose type or having a larger claw with multiple fingers so you can pick up any kind of object, which is something that we would definitely pursue given more time. But with what we were given, we decided to just not modify the sticks or the fingers because of time constraints. And one more constraint with doing that is when having multiple different models for the fingers, is you have to be able to take them apart. First off, that can be challenging for the users. And second, taking them apart, you have to find a way to be able to easily disconnect and maintain the connection between the tension wire and the fingers so that it still works after you've changed your fingers. So that would be like the biggest problem to try and overcome pursuing that design.
Okay, thank you very much, Daniel. We're at time for questions. And thank you to the rest of your team as well. Our final presentation will be from group D4. I'm not sure if this is an acronym, AJA or AJA. You can introduce your group name when you present.
Perfect. Okay. Hi, everyone. We are Group D4, and obviously our group name is an acronym, and our project is the Automatic Note Transcriber. Next slide. So why is this problem important? So our client, who is a young professional working in special education and an aspiring theater artist, wanted a product that would save them some time when they were note-taking because they found that they were losing a lot of invaluable time during this process. So with this in mind, we wanted to create a product that would streamline the online note-taking process for not only our client, but everybody with a variety of disabilities. Next slide.
That's right. So talking more about our sort of basic user requirements, after meeting with our client, we determined that we should put priority on making the solution easy to use, accurate in its transcription, and otherwise, because I mean, otherwise, how useful is it really? And also being time efficient given the time constraints that were the reason for the client's original problem. So given these generally defined problem, we got to work to develop a solution that would meet our clients' needs. So we came up with a number of concepts through the process of ranking the ideas based on target specifications. We determined this project plan from this. So our first prototype here was just a basic user interface that we drafted within Adobe XD to simulate the design flow. Our second prototype focused on the functional side and getting the OCR to work reliably. And finally, we brought these two prototypes together to create our automated note transcriber application, which I'll demo here.
As we can see, there are two buttons on the user interface, both straight and clear. The first button is for accessing the file. Explorer to choose the file need to be converted. The second button is converting the content into plain text. And there's a progress beside converting buttons to remind the user the completion of the task. There's a big text area at the bottom which will display the result after converting. We also have another option which the software will generate a TXT file in the computer so we can copy paste from there. The first example is a JPEG from our class PowerPoint. The font on the image is nice and clear, so we can estimate that the accuracy should be high. As we mentioned before, we click on the File Explorer and choose the targeted file and click on Convert. The result is nice and clear. And as we counted, the accuracy of this one is 100%. As we can see,
that is time.
As we can see.
So thank you very much, gentlemen. I'm sure if judges ask questions, if you didn't finish, you might be able to touch on some points in your presentation, but I will hand it over to the judges for 5 minutes, and the clients as well for 5 minutes of questions.
I'm curious to know, did you measure the accuracy of transcribing regular handwritten text of regular size and just handwritten?
Yeah, we did measure those, like handwritten text. We found that the accuracy dropped off to about 85%, especially when you consider things like formulas, like math formulas, just because you can't really accurately represent that in a plain text format. But with typical handwriting, like depending on how neat and clean it was, it usually performed pretty well.
Okay, if there's no other questions from the judges, I'll give them about another 30 seconds. But because this is the last presentation, I will just take the time to say thank you to all of the students for your presentations today. Super interesting ideas and super interesting approaches to solving these problems. I'm curious to go back and see the other what the other groups have done to take on these challenges as well. So great job. Are there any other questions from the judges or the clients for group D4?
I just have a comment. I think great job to all. You guys have all explored some interesting ideas and done a fantastic job of coming up with solutions.
Thank you. If there's any, before we depart or into different rooms, this is usually, it helps with the judges' deliberation. If any of the clients just want to take a couple of moments, if you are in here, to speak about what your problem was before even engaging with the students, it does help the judges kind of pinpoint did they really hit the mark. So if you'd like to take a minute or so just to talk about your own experience, that would be great.
Yeah, I can share. My video is not starting for some reason, but anyway, it's Roy Ballantyne. I'm working with a fellow who has CP, and effectively no speech and minimal use. And so he wanted to communicate with his caregivers and also communicate with devices around his home so that he could use smart devices, TV, etc. So the two TalkBox projects you saw were to address those needs. The students both groups chose to use a joystick. My client can only use a single button, but the students had the freedom to choose other interfaces. And as I think they pointed out, their joystick can be operated just as though it was a single button, but you would have to modify the user interface a little bit.
Okay,